All right, I'm here with Scott from Space and Time. What's up, Scott?
Hey Joe, how's it going? Great to be here.
Awesome, awesome. So, look, I wanted to have Space and Time on the pod because I learned about y'all a few months ago, maybe a year ago, even at this point, and I just thought it was a totally different, novel type of product from what you typically see in the crypto space. And so, been following y'all ever since. But yeah, I just wanted to get you on here so that everyone can learn more about what you're working on because I think it's super compelling. So, maybe just start off with your background, where'd you come from, and how does that tie into starting Space and Time?
Yeah, absolutely. I spent about a decade in the data warehousing industry working for a company called Teradata, which is a Fortune 500 data warehousing company that has one of the longest, oldest, probably most mature data warehousing query engines that exist today. They kind of pioneered the industry. A lot of that work was around like moving to the cloud and taking these monolithic 100, 300, 500 terabyte systems on premise that power Fortune 500 companies like Apple and Walmart and Wells Fargo and Southwest Airlines, and bringing those to the cloud is kind of a interesting process to sort of be centralizing the world's data into these analytic black boxes owned by mega corporations, and to now be working on something decentralized where the focus is on like bringing ownership of data back to the Web3 community, back to the constituents of the internet.
So, what problem does Space and Time solve?
Right now, the main focus of Space and Time is around making smart contracts smarter. The problem is that smart contracts don't have access to any data on their own chain, much less other chains, even more, much less off chain, right? Like smart contracts can't even ask basic questions about data on their own chain. Like a smart contract can't ask, how many transactions has Joe performed on chain, or show me all liquidity pools with a TVL greater than 1 million, or show me all wallets that have at least a 1 year of age on chain and have at least 10 transactions. As an example, those simple kinds of questions today, that's a smart contract, especially in the EVM, cannot answer, and they don't have access to data on their own chain. We've built a trustless, cryptographically secure, cryptographically provable way to provide that data to smart contracts without breaking the trust model of the blockchain. Now, why we refer to that as sort of a data warehouse, or why we talk about data warehousing in that context, is we are indexing and storing 100 terabytes of data across a bunch of different chains, all these popular EVM and non-EVM chains, and we're warehousing that data on behalf of our users such that our zero knowledge proofs, our cryptographic proofs on that data can be performed at scale. Space and Time is a way to provide trustless data to smart contracts and solve the problem of smart contracts actually not being that smart today. But we have to warehouse 100 terabytes plus of data in order to solve that problem across multiple chains.
Okay, so you said this word data warehouse. So, folks may have heard of a product like a Snowflake, for example.
Yeah,
So, could you talk about just data lake versus data warehouse, and how are you the same or different than Snowflake?
Yeah, so Snowflake is probably the most popular and highest valued data warehouse. They were one of the largest IPOs in history, especially in the data warehousing space. And what they are is they're a cloud-based distributed cluster of compute on AWS and Azure and GCP. Snowflake is just a system that can query data at extreme scale across hundreds of servers. And those hundreds of servers live on AWS, Azure, and GCP. It's just all a data warehouse is just a database scaled up to distributed scale, where you have, instead of one server like a PostgreSQL server serving database queries, a data warehouse is usually doing that at extreme scale times hundreds of terabytes or even tens of terabytes. And the word data lake evolved because what people realize is you can just dump all of your data, your terabytes of data, into AWS S3 or Google Cloud Storage or Azure Blob, and you can just leave it there. And there are new query engines that you can just bring to your cloud object storage that just kind of query data just in time, just when needed. You don't have to persist data on expensive servers on the local SSDs of those expensive servers. You can just dump your data into cloud object storage and bring a query engine to it when you need it. That's kind of how the marketing term data lake evolved. Is like a warehouse was generally referred to as like servers persisting data A data lake is just like, hey, just dump everything into cheap object storage and bring your query engine whenever you need it. Sort of a different architecture, ultimately doing the same thing. Ultimately, it's large scale storage for a lot of enterprise data and a query engine to access it. The way we think about it is this. What we're doing is we're grabbing or indexing data from a large number of popular chains, and we're prepping that data to be stored in the space and time storage engine, like a decentralized storage engine underneath space and time. And we're warehousing that data or persisting that data times 20 chains times 2 terabytes a year per chain on average, and it starts to add up quick. And then we have a zero knowledge provable query engine, a query engine that we built with zero knowledge capabilities embedded to actually query that data, but prove that the data itself has not been tampered, that the actual query execution has not been tampered, which is something that doesn't exist today in Web 2, doesn't even exist in Web 3 yet until space and time. Long explanation just to say, data warehouse, persisting data on your local SSDs of your server. Data lake generally means just dumping data into cloud object storage, and space and time takes those concepts and brings them to Web3 with cryptographic proof.
Gotcha. So I want to come back to what you said about tamper-proof and verifiable data, just for the audience. So, when you say data, there's different types of data. Generally speaking, there's two types of databases. One that's more of a traditional table structure, and then there's these other ones like Mongo, maybe where there's other assets like imagery and other things that can be stored. So is that kind of where you're going with all this, where it's super flexible, super open, or where are the bounds of it, necessarily?
Yeah, great question. What we support today is just tabular data, relational data to be queried with SQL. Today, we don't support JSON objects like MongoDB does. You have to store your data in a relational format.
Gotcha. I know that blockchains are kind of run by nodes. There's all this data from the blockchains, but it's not organized very well. So there's other products on the market that people may have heard of as well, kind of like the graph, and they're trying to organize data into subgraphs. So just again, for maybe a comparison, how is space and time similar or different from something like the graph?
I actually have a ton of respect for the graph. I think they're very pioneering in the space. In a way, space and time is sort of an evolution of that. What the graph did is the graph took PostgreSQL databases, built a little indexer around Postgres that can run on the same server, and then just deployed a big network of these servers hosted by the community all over the globe of little servers that are grabbing small pieces of blockchain data. They're not grabbing the entire chain. They're just grabbing specific smart contract events that a user cares about, pinning those or indexing those contracts, getting that data into the Postgres server, pinning it to the Postgres server, and making it available for queries. Now, the beauty of that is, A, it's easy to set up if you just need data from a couple smart contracts. And B, it's Postgres compatible, which is a familiar database that everyone already knows and is comfortable with. And also, it's decentralized. Like, these nodes are operated by the community. While that's super helpful, especially for developers that need to get blockchain data, the inevitable next step is that developers then want to connect that data back to their smart contracts on chain. They want to be able to allow smart contracts to access that data, not just their analytic dashboards, not just their apps, not just like front ends that need to show data, query tools, but they also need their smart contract to access that data. And what the graph never evolved into was a trustless or cryptographically guaranteed or cryptographically proven query engine. While the graph grabs indexed data and allows you to query it, the graph cannot prove that indexed data is correct. And that presents a problem for developers. If you can't prove that the data you've indexed is correct, then there's always this concern that, okay, well, it'd be very easy to tamper or manipulate that data. It'd be very easy to log into that Postgres database running on your graph server and just change a few rows of data and do things like change wallet balances, transfer tokens, change the price of Avalanche. Like, you could manipulate that data very easy if it's not proven. So what we realized was, hey, there's two opportunities for us to really evolve the space. One is store entire copies of the entire chain, not just specific smart contract events. Just grab the whole thing. Just give the customer the entire chain, not just the 2 or 3 or 5 smart contracts they care about. That, and then also prove it. Prove to the customer, the Web3 developer, that the data you've indexed is accurate, tamper-proof, it's been indexed correctly, it's cryptographically proven.
Yeah, I agree. I mean, the graph, I see it used all over the ecosystem. I think it was a huge help. And I think what you're saying is you guys are kind of evolving this next phase or this next layer of what's going to be needed for verifiability. So maybe again, for context for everyone, just talk through, maybe even from a Web 2 lens, the problem with databases. I mean, there could be hackers trying to get into the database to change data, or internally, maybe someone's making an update and they just screw something up. So maybe talk through a little bit about the problem you solved just with that tamper proof, because that's what you're saying with tamper proof, how a database can get messed up, which is, catastrophic for companies.
Yeah, I'll start with the most obvious, which is that we've seen lots of hacks in Web3. I mean, we're talking about $1 billion of hacks at least, where whether it was an internal job or not, we're pretty confident that some engineers or developers or hackers got into a database server centralized off-chain, which was powering an on-chain protocol, like a DeFi protocol or a DEX. And then just with access to the database, just update a few rows of data, change a few things, like change the price of an option, change the price of a perp, change the price of a spot token price, and basically mint rewards for themselves on chain as one of the, I would say, the most prominent hacks in Web3. But what had happened was protocols had gotten to a point where they were developing in sophistication, right? Web3 DeFi focused protocols that are building more sophisticated financial instruments and moving the computation and storage and processing of data for those financial instruments off chain to a centralized server, a centralized database that they operate and run. And of course, when you do that, the problem becomes, well, your own engineers can just log into that database and change their own balance in your DeFi protocol or change the price of a token and basically just manipulate things downstream on chain. And so that's one area. Another area is the centralized exchanges that we found out later hadn't been actually purchasing crypto on behalf of its customers when customers sent fiat to onboard to crypto. Like I go send $50,000 in an ACH wire transfer to FTX for FTX to purchase and custody Bitcoin on my behalf, but they never do. And they run their own centralized database where they can manipulate things in the database and say in the database that they did purchase Bitcoin on my behalf, so that when I log into FTX, it looks like I have an account balance of Bitcoin because it's just in a database off chain, centralized, easy to manipulate. So those are the two areas that I see being the most obvious. But when you get deep into Web3, I mean, while those are the two areas that are most obvious, that's actually not the two areas that we believe really will drive the most value for space and time. The most value for space and time is driven by enabling developers to build smart contracts that are more data-driven, that are more sophisticated, building new on-chain experiences that you couldn't prior, because to do it prior, you would have had to build it completely centralized. There's this whole cohort of developers that care about decentralization and care about trustlessness and care about being cryptographically proven and not breaking the trust model of the blockchain. And they're trying to build more sophisticated on-chain applications, but they can't today because to do that, they would need a database. They need their smart contracts to be able to query on-chain data.
It does. So I'll sum it up to see if I've got it, and then for the audience too. So data gets ingested into a database. So from that time until it's used in a query, you can prove that it hasn't been manipulated or touched. Then the result that's actually sent to whoever's doing the query, you can prove that that's an accurate, computation of what the data used was for. And then you can make sure that the query itself, the actual what did I ask for, wasn't tampered with as well to be changed. So there's kind of like a 3-step of data goes in, data gets accessed, whatever is asked for is also true at the query. Is that kind of a good summary?
Yeah, absolutely.
Excellent. So tell me more about this blending of, there's blockchain data, but then there's a lot of other data in the world that's not on chain yet. It's offline per se. You looking at doing things with that as well, supporting that? Is there, oracles involved here?
Yeah, exactly. So far we've just talked about one half of the sort of ecosystem of data, which is just getting data from chains, indexing, collecting data from the blockchains, making it available to query either by just users that want to populate Dune style charts and dashboards or by smart contracts directly. The other half of it is, well, there's all kinds of use cases where developers want to bring data from the non-Web3 world, from off-chain to Web3, bring it on-chain. Like enterprises that have a lot of traditional business data living in cloud data warehouses or cloud data lakes, and they need to connect that to their smart contracts. So think about like a credit card company that wants to build a loyalty system on chain where you can use your credit card loyalty points you've earned and redeem them for crypto, as an example, or redeem them for NFTs or something, right? They would have to connect their traditional cloud Web 2 data warehousing systems directly to their smart contract on chain for their smart contract to know, hey, when Scott connects his wallet, how many loyalty points does he have with that credit card company? If I have 30,000 points, how does the smart contract know that? And how do they translate that over to crypto and allow me to use my points to redeem for rewards on chain? That's just a fun example, trying to illustrate this idea of bringing off-chain data on-chain. Pre-space and time, to do that, you'd basically just be connecting a centralized system via an oracle directly to your smart contract. Nothing wrong with that approach, but of course, there's no proof in that approach. So you still have the same issue where anywhere along the way, from source database to Oracle to relayer servers, like it'd be very easy to manipulate that data and just say Scott has 5 million loyalty points when he only has 50,000. And maybe 50,000 loyalty points would have translated to like $1,000 of Ethereum on chain. But if I just manipulate that data in the centralized source system and say, okay, well, actually Scott has 5 million points, then I could mint for myself, like 100 grand of crypto that I could steal on chain. I'm using this to illustrate, like there's all kinds of exciting use cases, mainly in the financial sector, where Web 2 financial enterprises want to bring traditional data to their smart contracts on chain. They're starting to build on-chain systems and they need to enable those.
You have customers today, that's correct?
Yes, we have about 30 that are large, like 30 enterprises building on space and time.
Awesome. So who are you typically talking to? Is this a CIO, a CISO, a CTO? And then do they get this tamper-proof problem, this verified data problem, or is this something that you've got to educate them on a lot to kind of see the future?
It definitely takes some education, but they generally have already been educated by some of their own like architects and engineers that this is a problem that's going to eventually need to be solved. At the enterprise level, it's like a SVP of digital transformation, an executive leading some kind of greenfield digital transformation effort, digital assets. Like, at some of these larger banks and financial institutions, it's like the senior vice president of digital assets, right? They usually have a digital assets team, small but growing, that are focused on building net new kind of greenfield use cases and have a budget to go build something on chain. That's at the enterprise level, the Web 2 enterprise level. On the Web 3 level, it's just CTOs, just me talking to other CTOs and talking shop. They're usually already a little bit educated that, hey, this is a problem. And they usually have teams internally that are trying to solve the problem themselves with some kind of internal architecture and struggling. Because it's not a problem that's easy to solve. I mean, really the only way we believe you can solve it is cryptography. Cryptographically proving that from source all the way through to smart contract, nothing was tampered. And the easiest way to prove that with cryptography is zero knowledge. Welcome to space and time.
Cool. So, I mean, we've talked about data warehouse. We've talked about proof of SQL for verifiability. You've talked about being able to query data. So I guess, and I also saw Houston, this new product that you've kind of been rolling out here. So can you just talk me through your product suite and maybe how it all ties together or the different use cases?
Yeah, absolutely. So a lot of people say, well, what is space and time? Are you guys like this ZK compute layer? Or like, are you doing zero knowledge? Or are you more of like a data warehouse? Are you more of like an AI analytic tool? Are you guys trying to build like an AI powered Dune? What do you really try to build space and time? Our strategy is actually really simple. Start low level, hardware, accelerated queries that run with a zero knowledge proof. We built a low level zero knowledge circuit to run on GPUs, execute queries at scale, and prove them. Step one. On top of that, well, we need data to run those queries against. So we go grab data, go get index data from all the chains, prep it, loaded into the database to be queried against. Step 3, how do you actually run a query? SQL. Well, some people don't want to write SQL, so we built a AI-powered SQL engine where you can just write natural language, build prompts in natural language, and we convert those to SQL for you and run them. We're just kind of going from the low-level GPU hardware accelerated architecture up the stack to the user. Start low level, fast query engine on GPUs with zero knowledge proofs. Next step, provide a query engine against that, and then finally allow users to use AI to write their queries. That's simple. We built a pretty forward-thinking prompt to SQL engine, so you can just like write your prompts. We convert it to accurate, valid SQL for you.
Cool. So you mentioned hardware accelerated queries. You mentioned natural language process-based SQL queries generation. What are you relying on? Do you need to have some big stable of GPUs to be able to use for all this, or how are you guys kind of?
Yeah, our zero knowledge proofs run on NVIDIA GPUs. We went that route for performance reasons. These mathematical computations that we're doing on data are very easy to parallelize across a GPU, and it can be accelerated quite a bit. I mean, we're talking like 5 to 10x performance improvement, worst case, GPU versus CPU. That's another area that we believe is forward thinking in the database, data warehousing space in general, is that like right now there are not really any data warehouses other than a new one from Voltron Data that are doing GPU accelerated queries. Most query engines just run on CPUs.
So I mean, there's a huge GPU shortage right now. Are you buying your own? Are you renting out of the cloud providers? Are you trying to use any of these Web3 GPU marketplaces?
Yeah, we have a great relationship with both NVIDIA and Microsoft. They're both partners of ours. Microsoft's also a backer of us, and we get a lot of help on the GPU side from Azure. So that's all I'll say.
Gotcha. Talk me through the Web3 part of this. So you don't have a token yet. Do you plan to have a token? And then you have validators or plans for validators? What do those do? How do those help the network?
Yeah, so on the token side, we intend to drop a token at some point in the next, hopefully 18 months, maybe sooner. But we've got a lot of work to do in the meantime. We're continuing to build out and incubate sort of the decentralized network piece of this. For those familiar with sort of zero knowledge and ZK coprocessors off chain, you're probably familiar that like with ZK, you don't really need a consensus driven network of nodes. You don't really need to deploy 100 validators that come to consensus. You really just need like 1 or 2 nodes that are generating proofs, because the proof with ZK comes from math and from cryptography, not from consensus. So what we have today is sort of like a small network of a few validators that are running these GPUs and building proofs. But before we drop a token, we want to solve a liveness problem, a high availability problem, where we want to decentralize to a large network of community provided hardware, not for the purposes of consensus across validators, but more for the purpose of censorship resistance and liveness, ensuring that there is always a sufficient number of nodes available in the network to accept query requests at any given time, so that we have 100% availability in a decentralized network. It's not about coming to consensus and building a blockchain of signed blocks. It's about having enough nodes available. So once we grow our network, we're planning to launch a space and time token and go from there.
My first episode here, which hasn't been released yet at the time of us recording, was with Akash Network, and they're a GPU marketplace, Web3 based. Someone like me can rent out my gaming GPU. Somebody else can rent it. What would you need to be able to kind of use a network like that?
You just need an NVIDIA GPU. We built our tech on the CUDA framework, which runs on NVIDIA GPUs. So aspirationally, we could definitely run on a gaming desktop from a kid in Switzerland or something, or Mumbai. We could do the same thing, right? Our node providers could be folks providing commodity hardware in their household. The challenge is this: you scale based on the amount of GPU computation available, and your query latency is also going to be dependent on that. We built a router that parses a query, determines how complex that query is, and routes it to the appropriate nodes in the network that have the compute capacity to handle a query that complex. So if we onboarded a global network of gaming desktops, they can run our proofs. We just have to route them queries that are simpler. queries that only query, for example, a couple million rows of data rather than a couple billion rows.
Gotcha. So you said you had 30 customers. That's awesome. What's some of the coolest use cases you've seen so far?
I'm really excited about all the use cases in DeFi, right? Like there's a protocol called Lenvest that's doing on-chain credit scores and building kind of a Web3 infrastructure for lenders. And they're, calculating those scores in a decentralized way and storing all those calculations in space and time to be queried by smart contracts like Aave, for example, or other lending protocols that they want to integrate with. I'm really excited about gaming in Web3. There's a lot of games that need to combine their off-chain in-game telemetry with their on-chain data around NFT mints and user activity on chain. And space and time becomes a single source of truth for those games to be able to join see what's happening in game and see what's happening on chain in one place. Finally, I'm really excited about, I've been talking for a long time about enterprises that are moving into Web3. Space and time is in a unique position to be able to witness this a lot more than other startups in Web3, only because of our relationship with Microsoft. They've been very helpful to us and brought us into a lot of enterprise conversations where big financial services companies, banks, even like I'm talking about American banks, like big American banks that you all are aware of, and massive financial services companies in America that we all are aware of are today building their own blockchains. They're building L2s, they're putting contracts on chain. They have entire teams dedicated to this. And we don't really hear about it as much because we just see like Jamie Dimon in the news trash talking Bitcoin. But what we don't know is like they've already deployed a bunch of stuff on chain. Like JP Morgan Chase is doing a ton of work on chain despite having kind of mixed emotions. So it's been really encouraging to watch all these enterprises start to think through the same challenges that space and time is, of like, hey, we have this big data warehouse off chain. This big data warehouse powers our business, holds our 100 terabytes of customer data. How the heck do we connect it to a smart contract? And they're trying to do that today. And that's very encouraging because it just means like, hey, floodgates are coming. They're going to open. Like 2024 is going to be a good year, baby.
I mean, one of the taglines I've seen, I forget if it was on your website or wherever, but it was basically the verify everything future. So tell me more about maybe just like, aside from space and time, like what are the problems here? Does this have to do with deep fakes? Is space and time something every company is going to have to look at using if they're using technology in any way, shape, or form?
Yeah, great question. It's not really about deepfakes. It's more about just having confidence that when you query a database, what you're getting back has not been tampered, that it's actually accurate data from the source. That source can be a blockchain. And we're doing a lot of work to ensure that to make that smooth. So when you want to get data from a chain, you can have cryptographic confidence that it's accurate, it's real, and it matches up perfectly with what's on chain. There hasn't been any tampering. But what if that source is not a blockchain? What if that source is a financial market, the stock market, or a derivatives exchange? Or what if that source of data is weather data from sensors in Florida tracking hurricanes for insurance payouts to homeowners based on wind speeds? Space and time, the verify everything future that we envision is this. When you have raw data, I'm not talking about images, I'm not talking about videos, I'm just talking about semi-structured or structured data coming from a source, you can be confident that by the time you query it, it has not been tampered. For example, if that source is weather sensors in Florida tracking hurricanes, tracking wind speeds, maybe there's an incentive for a bad actor to want to maybe manipulate that data and say there wasn't a hurricane when there really was. The wind speeds got over 120 miles an hour, and that constitutes maybe a hurricane. And that also constitutes a big insurance payout to homeowners or business owners in Florida. Maybe there's an incentive for a bad actor to want to manipulate that data and say, actually, we only clocked wind speeds of 118 miles an hour. Doesn't constitute a hurricane. None of you guys are getting an insurance payout. That's a Web 2 use case, but it really highlights the need for Web 3 style technology to fix that problem. That's why we need to verify this data. We see over and over and over, year after year, situations like that happening that don't come to light until years later. FTX was the best example of like years of them manipulating data in a database off chain, saying they're doing things that they're not, saying they're buying that Bitcoin for you when they're really not. And then you find out years later and, they erase $100 billion of value overnight, right?
I think that's a great example to keep going back to because it's quite literally verifying that what they said was true on phone calls. Was that actually the case on the back end? What's going through my head right now is basically that space and time is going to really improve, if not solve, kind of due diligence in a way for companies and then folks looking at these companies.
You said it perfectly. Due diligence. This is a great way to explain it. Thank you, Joe. If you didn't have space and time and you wanted some confidence that what an enterprise is saying they're actually doing, you'd have to bring in a third-party auditor, and you still have to trust that third-party auditor that they're not in collusion with the enterprise. And you also have to trust that third-party auditor to do their job well. Believe me, there were plenty of auditors that looked at FTX. It wasn't like they never got audited. I'm sure there was some due diligence, right? Like there was people looking at their database and saying, okay, it looks like they're buying Bitcoin. Okay, good. Looks like everything's smooth. Like it looks like they're doing, their books look reasonable. Of course, those books were cooked and they fooled the auditors. Prior to the advent of zero knowledge cryptography, you just have to manually go into the database, sort of almost like row by row, and just double check that things haven't been tampered, which is very, very challenging to do, if not impossible. So it really does solve the due diligence problem. The verify everything future is like verify that the protocols you're interacting with are actually doing what they claim to be doing. When you go buy a perp on DYDX, do you actually have exposure to that perp or not?
Another thought here is just, anyone who's maybe worked at corporations or software tech companies, maybe you've dealt with a SOC audit. SOC audits are so manual. And like you're saying, you're still trusting that third-party auditor. So perhaps in the future, part of the SOC audit is automated or verifiable with space and time, or it's just another aspect of the SOC audit of, hey, can we actually verify your data? That's just another checkbox, depending on how that goes. But just a lot of problems.
I think one key to highlight too is this becomes much more important when the data is valuable and there's an incentive for a bad actor to want to manipulate it. Like if you're just building like a social media app and you're storing people's comments, do you really need zero knowledge cryptography to prove that you haven't manipulated the comments and the likes? No, it's not valuable data. If you're just storing like in-game telemetry from a fun video game and you want to log every bullet fired in the game and every win and loss, like there's not a huge incentive for a bad actor to want to kind of breach a database and manipulate some things, right? You don't necessarily need this kind of verification for that specifically. Where it becomes really important is mainly in like when there's finances involved, when there's money changing hands, when this data is going to lead to an outcome that's a financial transaction. Using the hurricane in Florida example, like tracking the wind speeds in Florida doesn't seem like valuable data until it leads to a $100 billion payout, right? And then there's an incentive for someone to want to manipulate that data to not give the $100 billion payout. And so our mental model for thinking about this is like, hey, how valuable is a data set? Does it lead to downstream transactions? Are those downstream transactions massive? And therefore, is there an incentive for an internal employee, an external third party, or a hacker to try to get in and manipulate that data and change the transaction? In that case, you have to verify. Because if you don't, you end up in an FTX situation.
That makes total sense to me. So let me play devil's advocate for a minute. So where I was going with that deepfake question earlier was basically, what if somebody was to hack Twitter, edit a tweet, the tweet says something about, a war breaking out or some other kind of horrific event, which affects the markets then? How do you think about that in terms of actually verifying even the text on social networks or in-game data gets edited and people were betting on esports games, that could affect the outcome there. I mean, is this extendable to that?
The concepts and the technology are absolutely extendable to mixed media, to unstructured data, to large text corpuses for news events. When I think of unstructured data, I think of like news, big news documents, or a video of a prime minister doing something he's not supposed to that was deepfaked, referencing like a Black Mirror episode there. Space and time today is focused on structured and semi-structured data. Today we support tabular relational SQL data, and we're soon adding support for like JSON and vector embeddings and things like that, things that are semi-structured. There are other startups in the space that are a little more focused on the unstructured side of things, that are sort of using space and time style technology, using novel cryptographic methods to sort of like watermark an image or a video and kind of prove that it hasn't been manipulated from the source. Same concept still applies. It's relevant when that manipulated image or manipulated video or manipulated news article leads to a financial outcome or a political outcome, right? There's a huge incentive for a bad actor to want to do that. While space and time focuses more on structured and semi-structured data, wink, wink, blockchain data, there are plenty of startups that are more focused on videos and images. And part of our partnership with Microsoft is like engaging with those other startups. Like Microsoft invested in another startup called TruePic. Microsoft sees the value in like this whole verifiable future as AI becomes more prevalent. Like in a world where AI generates everything, the only thing that matters is verification. So while they invested in space and time for structured data verification, they invested in a company called TruePic for unstructured data verification to like watermark images and prove that they weren't doctored.
Gotcha. That makes total sense. Okay. That was awesome. So I got a fun one for you, and I'll send you the link in the chat here. So about a week ago, you sent out a tweet and you were basically talking through kind of the stages of the web, let's just say. And so I'll just read them off quick for everyone. So it was kind of Web 1, document, Web 2, interact, Web 2.5, share, Web 3, own, that's where we are, Web 3.5, generate, Web 4, verify, and then after that, keyless web, quantum, biometric web, neural, exist in two particular states at the same time web, and then lastly, the sentient web, singularity. I would love for you to just talk me through each of those, because I was like, this is awesome.
Yeah, I mean, if you take a step back, just start to label the different stages of the internet based on the activities you do in them. Like Web 1 in 2000 was just like build a document, share it, like an HTML page. And then we came across like interactivity apps. There was the bloom of the iPhone that led to a bloom of applications where you interact with your phone and you interact with the web. And then that led to social media around the time I was a kid. You know, like I remember, I think I was a freshman in high school when I got on Facebook or something. I don't remember, but you know, that led to sharing, not just interacting with an app, but actually sharing that with friends. And then we get into the fun part of the discussion. So Web3 then said, okay, cool. Don't just share, don't just interact, own. You should take self-custody of assets, of data. I struggle to think, okay, is verify come next or does generate come next? Actually, I believe generate will be 3.5. I think generate comes before verify, and here's why. So if Web3 is the 2021 era of the web, focused more on owning, the next era that we're seeing in 2023 and probably really blossoming in 2024 is generating, right? Like everything's generative. And we just saw an announcement from Google that the Google Gemini announcement where they're generating your user interface for you just in time. Kind of a chatbot that generates a whole new user experience, not just the text in the chatbot, but the whole visualization of the chatbot generated in real time. Going back to this whole discussion on the verify anything future or verify everything future is like, if the web becomes fully generative and everything is generated, that really means everything's fake, right? That really means the only thing that matters in Web 3.5, the generative web, is verification. Because in a world where everything is generated, the only thing you're going to want as a consumer is confidence that the systems you're interacting are real, verified. When you watch a movie, like when you go on Twitter and you see an announcement about a stock that you're invested in or a crypto project that you're invested in or about a political outcome, like you're not going to know if that's real or not. You'll have no idea. Everything will be generated. Everything will be fake. And so the only thing that matters then is verifying. Cryptographic systems that can prove that a certain piece of content you're interacting with wasn't generated, is actually real from a source. So what I see is the self-custodial web, the decentralized self-custodial web evolving into a generated web, and then kind of backtracking to a decentralized verifiable web in Web 4. Does that make sense?
It does. It does.
Like a natural follow-up to the generation of the web would be, oh crap, now we have a fake web, we need to verify it.
No, I mean, it's what you said. It's like everything's going to be fake, so what's real? You've got to have a way to know.
Yeah, and then beyond that, quantum will force us to not be able to use private keys anymore. And we'll have to think of new encryption schemes that are quantum safe. So I would imagine 7, 8 years from now, you won't be able to use your MetaMask wallet. You won't have standard encryption curves because they won't be quantum safe. So you'll have the keyless web, beyond the verified web. And then what will that evolve into? Probably something biometric, like, I imagine like some kind of neural implant. I don't know. And then beyond that, just pure sentience, the singularity, right? The web just kind of, machines just become smarter than humans and just move on without us. Godspeed.
Godspeed. That's awesome. Let's imagine that, it's a year from now, we're meeting again. What do you hope to be telling me about with space and time?
Good question. 2024 is going to be a big year for us because we're sort of building phase 2 of space and time, which is getting really good at decentralization, making it really easy for node operators to run. For the listeners, I met Joe sort of in an engagement around like, how do we onboard some more node operators? Joe was leading some product at a company that does like large scale node operations. And we were thinking, okay, hey, space and time can make you guys one of our node providers. At the time, we realized as we started to roll out our node operations at the time, we realized we're kind of a little too early. Like, it was too difficult to deploy space and time quickly and easily, and it was requiring like node operators to be a little too hands-on. So all throughout 2024, we're doing hard work to make it just remarkably simple to deploy space and time. Like, one-click Docker container. You don't need a big Kubernetes cluster. You don't need a whole cluster of servers. You can just deploy on a single server, run a validator, and get up and running. Because we do have that vision of like getting space and time running on a gaming desktop from a kid in Mumbai, or getting space and time running on a single server in someone's basement in Switzerland. That's the goal. And so 2024 is moving towards that goal. So I imagine if we talk a year from now, December 2024, I'll be proud of the network of node operators that we've onboarded via making it easier to do so and starting to build out our decentralized network. That's really the last thing we need to do before we drop a token. So you can wink, wink, imagine what 2025 is going to be.
Amazing. Hey, I learned a lot in this episode. I mean, I was already familiar with you guys, researching you, keeping up, but I still learned something here. So this was amazing. Thank you. Where can people learn more about space and time or follow you?
Yeah, at Chief Bildle, at Space and Time DB on Twitter. Go follow at Space and Time DB. If you want to follow me directly, it's at Chief Bildle. Spaceandtime.io if you want to check out our docs and our tech and start to use our app and start to generate some queries with AI. And then finally, we have a pretty poppin' Discord. Wink, wink, as part of this build towards the space and time token, we're starting to get a lot more active on Discord with quests and points and engagement from the community that will lead to points that are wink, wink associated with a future token launch. That's all I'm going to say. So if you want to get involved in the community, Discord's a great place to start, or follow Space and Time DB on Twitter.
Perfect. Scott, thank you so much. Appreciate it. Can't wait to get this out.
It's been a blast, Joe. Talk soon, my friend.